Hello, AP Chemistry students, and welcome to your final video for your Unit 3, which is Lesson 5, which is all about Bohr diagrams and electron configurations. So, Bohr diagrams. Remember, we've talked about that the atom has gone through many theories. So, Bohr is one of the most precise scientists to theorize the atom so far. He stated that the atom must be in specific paths called orbits. And he also said that this is what led to our planetary model. So basically we have protons and neutrons in the center of the atom, and then the electrons are going to be floating around in the orbits around the outside of the atom. So when you're drawing Bohr diagrams or when you're analyzing Bohr diagrams, each electron has a specific amount of energy that it keeps it away from the nucleus. So the farther the electron is away from the nucleus, the more energy it has. Electrons are going to be grouped into energy levels that are going to be dependent on their energy. And remember that electrons cannot limbo between two levels. However, they can jump from one level to the next. So electrons start in the lowest energy level permitted, and that is what we call the ground state. Energy can be absorbed, and electrons will move up to a higher energy level, and that is what we call the excited state. The first energy level can hold 2 electrons. The second energy level can hold 8 electrons. The third energy level can hold 18 electrons. And the fourth energy level can hold 32 electrons. When you're looking at this, and if you look at the periodic table, if you count across how many elements are in each row, row 2, row 1, row 3, and row 4 on the periodic table, you'll see where we can get some of these numbers. So from Bohr's diagrams, we can construct the electron configuration. The electron configuration shows how many electrons are in each level and each type of orbit. Remember, each energy level has a specific type of orbit. So when we look at this picture on the right, if you're in the first energy level, then you only have s orbitals. If you're in the second energy level, you have 2 types of orbitals, s and p. If you're in the third, you have s, p, and d, and so on and so forth. This is a picture that I use with all of my students to help them fill in electron configurations. So once again, remember there are 4 types of orbitals, s, p, d, and f. And based on what energy level you're in on the orbital diagram or in the Bohr diagram will depend on which kind of orbital you'll have in that diagram. So electron configuration. So when you're writing electron configurations, you want to remember these steps. First, you're going to determine how many electrons are in the atom. Then you're going to arrange the energy sublevels according to increasing energy. So it'll go 1s, then 2s, then 2p, 3s, 3p, 4s, 3d, so on and so forth. Again, look at the triangle diagram that shows exactly where everything needs to go. Then you're going to fill each sublevel to the maximum with electrons until you have used all of the electrons in the atom. And then finally, just double check. Make sure you're going to sum up the superscripts to make sure that the sum is equal to the atomic number of the atom or the number of electrons that you started off with. Here's another diagram that will help you. Remember, you have to make sure that you are writing these electron configurations correctly. We're going to talk about this in class, but I want to refresh before you come in on day 1. Now, from these electrons and jumping and releasing and absorbing energy, we get the electromagnetic spectrum. So the electromagnetic spectrum ranges from radio waves all the way to gamma ray. The visible spectrum is what we see. That's where we get our colors from. And remember, it goes from, if we're looking from left to right, we go from long wavelengths. In radio waves, they're going to have red light to short wavelengths in gamma rays. You can see how those waves are very, very, very close together. So now let's talk about the light spectra. Energy is released in quanta or packets to produce light. When light is passed through a prism, the colors may be seen at various wavelengths. We did this when we did the bright lights lab, when we stuck all those different chemicals into the Bunsen burners, and they different colors because of what elements and how the electrons were moving. Bohr was able to measure the energy emitted to create his quantum model of the atom. So the quantum model of the atom is the newest of all the theories of the atom, and this theory states that there is no actual way of knowing where electrons are at any time due to their small size and the fact that they are moving very quickly. So now we can only provide a probability of where the electrons are. So we can say about where they are in space, but we cannot know exactly. Just remember that protons and neutrons always are going to remain within the nucleus.